AP Physics 1's Thursday review session. However, it also applies to AP Physics C simply because there's obviously overlap, hey, Anish, about those things. And so if you may have seen this part of the first part of the video, which is going to be the terms, you can fast forward through that obviously, but this is non-content ACT prep. APP science testing words, and these are words you want to make sure you have so that you're kind of clear on what you're supposed to do for these words. So we've got brief explanation, which is a short, maybe like 2 sentences, make it to the point. One of the things they went over in the ACT thing that I had last Tuesday, and I put a video up, I believe Wednesday, was they technically are giving you 5 pages per question. But that was very specifically geared for history and English. If you guys answer something with 5 pages, literally the graders might just shut down and give no points. So be careful of that. If it says brief, it should be 2 sentences at most. A paragraph is where you get 3 or 4 more sentences. 3 or 4 sentences, you go into every aspect of the answer, sometimes more than you think is necessary, and that's important. I did highlight in one of the tests about how I had to add something extra, even though I didn't think it was necessary, because that's what their rubric called for. Explicitly, this is the one that is the most definitive or most in depth, as they say. This will combine, you're going to, you're probably going to have equations in paragraph, but you're definitely going to have equations in explicitly. You're going to explain every step you did and why you did them. This is very much like the defend your answer type thing. Even simple things like, hey, data came from a line, not from points on the table. If you did a best fit line, you had to get the slope. So explicitly is very, very sure. It's basically trying to like go step by step, solving the problem and explaining every detail of it. All right, so these are official AP terms. I'm just going to put them on the screen. You can go back to You can go back to the last session that I did for either class to have these terms. But these are actually in the. You can find them on my AP. They're just different words and what they mean. So you want to make sure you're clear on what things are literally asking for. And like if you did a paragraph and you only wrote 2 sentences, if you did I will guarantee you won't get all the points because there's simply that's going to be like a 4-point per thing, and explicitly will often be a 5-point thing. So just be aware of that. Explain is kind of like explicit, but it's a little different. You can see it. Justified, support, obviously. Now, label you won't need to worry about. Plot you won't need to worry about. Sketch or draw, don't have to worry about. State, indicator, circle, you might have to. I'm not quite sure. That one might be there. Verify definitely could be there. That's basically where they give you the answer and they say prove that this is the answer. Now, a quick reference guide. So when you guys have your test, you're obviously going to want to have a bunch of resources out. I do go into detail about what things you should have, like you want a quiet place. You want to make sure that everyone in the household knows what's going on, and you ask them to stay off the internet. Things like Fortnite, any sort of e-game is going to just, even through like a console, even if it's not a PC, it's just going to suck bandwidth. And you're going to want people not to be using Netflix. And that's literally why they made the test 45 minutes, because they could have easily made it 3 hours, but they're like, no family's going to give up 3 hours of internet time when there's nothing to do. So that's one of the big reasons they made it 45 minutes, because that might be more of a doable sacrifice, so to speak. But a quick reference guide, literally what this is this is what I use to make a cheat sheet. And then I went and did in Microsoft Word, find, replace, and wherever it says cheat sheet, I made it to quick reference guide. Cheat sheets are usually 1 page, whereas in quick reference guides can be multiple. And so you're going to want to, this is sort of how you'd want to do it in the future. After each set of your notes every day, you want to sort of jot down just the important things on a separate page. Or if you're doing the videos, like I hope you're doing, you might want to do that with these. I know some of them have summary pages, the really good ones. Some of the other people don't have summary pages, but summary pages are a good place to get sort of the key points you might want to put on there. Write them out by hand if you can. They're going to be cleaner, easier to read. If your handwriting is atrocious, then you can later type them up if you want. That's something that I would often do, but I would still handwrite them out. On a quick reference guide, focus mainly on what is being covered. So go over the important stuff, the really important stuff. Again, that's going to be what that summary page is a good thing. Things to include on a quick reference guide. But by the way, guys, you can have your notes out in this. People have asked, can you have online notes? You can. You need to understand that if those online notes are shared, that is going to ding in their system, and they're going to call that cheating. So if you made notes with a friend, you need to download it onto your device separately. I recommend printing them off. But they're going to know. I mean, I talk about it in the video that Hollywood is very good at tracking social media, whether it's dark or not. And they're going to know, they're going to be looking for that. That's literally something Hollywood does. We met one of the guys where I used to work who did the social media monitoring for the show Blackish. It was incredible what he could talk about. He could see about hashtags and then just anything that had mentioned stuff like that. And something I didn't mention in the video, they're literally going to put out misinformation on social media. So if people are using it, it'll mess them up. Literally, that's actually in the video I talked about. Formula is not on your formula sheet. You're going to have your formula sheet. You want to make sure you have it printed out. you also make sure you have the formulas we've talked about that are not on there that you're going to want there. Example problems worked out with the steps, and that's where you get to that explicitly. Reminder of things to look out for in doing a problem. So, there's things like elastic and inelastic. Elastic is conservation of momentum and kinetic energy, where inelastic is not. Any rules, that's going to be one of those rules. Stay away. Problems, you're going to want to do, I can't see everything because there's like these weird windows that come up. Let's see here. Terms and definitions, especially the ones that you might be a little confused on. I will be getting to the problem shortly. I'm kind of rushing through this, but I want to make sure it's on the video. Use old exams. I forgot to do this yesterday for AP1. I did it for APC. I will be putting up the progress checks for AP1 as well. They're worth 5 points on any exam this semester for every one you complete. But you don't have to use them to study from, because there are other resources that might be even better to study from that are more designed for this specific test, whereas those are not. So you can actually do them afterwards. They'll be due the 15th after everyone's done. But those are good to look at to see what they are. The people who wrote those questions are writing these questions as well. Many of the AP videos have summary pages, a good place to look. Now, in the textbook, you'll be like, oh, we don't have a textbook, Mr. Cooper. Well, you actually do. You actually have multiple textbooks. I have put them online. They might be an older, post, but you can find them, and it'll have each section individually there, but it'll also have on the top of that resource page, it will have the whole textbook. And you can look at the summaries of each of those chapters that apply to you, and that's another place to get good information. All right, enough of that. Let's go to our question. So this question was definitely hard. I was surprised at this question. Like I did the question, and I'm like, okay, I think I know what the answer is, but I wasn't quite sure. And so here we have our question. And like I said, this can be an AP Physics 1 or an AP Physics C question. And just as you guys look at this, if you want to type out or just talk, what are some things that you might want to pay attention to in this? What are some of the important things in this problem you're going to want to pay attention to? And Anish, if you can't talk, you can type.
Friction, you would need to remember about, like, incline on a plane. You would need to realize all those ideas, I guess.
But where is the friction?
The friction is on the rough part, D.
Correct. Is there any friction on this ramp, L?
None.
No.
None. That's right. There's none. So what does that mean?
All of the gravity is directly being converted into movement onto that block.
In a sense, this thing right here is not at all important. All it does is sort of change the direction so you can smoothly go into here. But there's no difference between the speed at the end of this and if you were to drop it straight down. So that's going to be your first indicator about this problem. So the L and the mu, are they at all related?
No.
No, they're not. And that's the thing that stumped me the most when I did this.
Why?
And I'm actually, the mu has nothing to do with the L. If this L is 5 bazillion feet long or 5 inches long, it has nothing to do with the mu because there's no mu on it. The mu is only here in the D area, this part where it's got this extra gray part area. So it's only there that the mu is. And that's important to understand. So that's kind of a neat little piece about this. And that's what confused me the most on this, because usually when they give you these, they're interesting. And when I did my work, and I'll show you my work in just a second, I kept trying to put L in there and I couldn't get it in there in any form that made any sense. And so kind of let me show you how I did this. So again, this is a weird one, and I of course can't. Can someone read me what it's asked to find? State all the aspects of the equation that are. And this is where it blocks out for me. What do you guys see?
That are plausible and explain your reasoning.
Okay, very good. So they're plausible and explain your reasoning. So basically, these are really hard questions for me to do because I'm like, well, I have to prove that it's either right or wrong, even though parts of it might be right and parts of it might be wrong. And that's where I struggle with this. So first thing I did was I did a sum of the equation F equals ma, and you actually had to do this twice. I did mu k equals mg, right? So if mu k equals, mu k mg, that's my force friction. And that's it. What direction am I obviously talking about there?
And talking about the downward, like, angle force. Sorry.
Sure. So it's going to be kind of your downward force. So mu k mg. So acceleration is mu k G, because you got M on both sides. That's talking about, by the way, just to be clear, when you're just start on D. So if we go back to our picture, that's talking about once you get here, the only force acting on this in this direction, you've got gravity this way, up and down. But as far as left and right, it was mu K mg, is because there's only a force friction, right? There's no air resistance, there's no push anymore. So it's once it gets onto this D part of the ramp. So that made that clear. And the mass doesn't matter because it cancels out. So okay, so I know what acceleration is. Once it gets off the ramp, it's mu kg. Okay. But I also know there is a sum of the forces on the L. That's the ramp. Is equals ma. I know that. And mg sine theta is going to be the only thing acting on it, right? So you've got gravity, but we're going down the ramp, so we want that component of it. So in this case, acceleration is g sine theta. Everybody with me there so far?
Yes.
So if we go back to our picture real quick, so I've got mu k g right here is this acceleration, and then g sine theta is this acceleration. There's no friction, so it's just g sine theta.
Mm-hmm.
All right.
I'm just saying for the sake of.
Okay, so I did that, and then I'm thinking, all right, I need to obviously do some other stuff because that's not enough. What would be the energy or the speed? If I want speed, and my first thought when I think of speed is actually not kinematics. I usually go to energy. I've got mgh equals 1/2 mv squared, right? Because all of that potential energy up there, because there's no gravity. If there was gravity, I'd have to do a whole bunch of, no friction. If there's friction on that ramp, I'd have to do stuff different. But all that friction on top of the ramp, all that, potential energy turns into kinetic energy by the bottom. So all of your potential, that height h equals 1/2 mv squared. And so that's going to turn into v equals, and your m's are going to cancel out. You're going to have the square root of 2gh. And we've seen that before, actually. We've seen that as far as the velocity at the bottom of if you drop something. So now I have an equation for velocity. But if I remember, the equation they wanted to solve for was like d, right? Wasn't it d equals something?
D equals.
Right here, yeah, d equals mu hl. So I've got to somehow figure out how do I solve for d. So I know what the velocity is. I know what the acceleration is, right? So now I can start messing with some kinematics here. So vf squared equals vi squared plus 2a delta x. That's my base equation there. That's equation number 5. Ooh, we just switched off here. You guys see the PowerPoint or no?
No, I don't see it.
Okay.
Me neither.
How about now?
Yeah, we can
Yeah.
see.
That was weird. Okay, hold on a second. Okay, there we go. There we go. There we go. Boom, 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 boom. So that's equation 5, and this is just solving for delta x. And in this case, delta x is obviously represented by letter D. Okay, I just put delta x in there because that's what it turns into. All I did was a little algebra here. Just subtract over the vi squared and divide by 2a. I get delta x equals this. This is equation 5. But I'm going to start to put in what I know. Now this is the speed once it gets onto that D thing, that bottom of the ramp. I know that my final velocity is going to be 0 because it stops. I know, that's actually all I really did there. So there's 2a, and yeah, okay, boom. Now I'm going to plug in some more stuff. D, which is my delta x, equals 2gh. Why is it 2gh? Because it's the squared of a square root. Everyone see that? Yes, no, maybe?
Mm-hmm.
Okay. Mu k g over here. And what happens to my g's here?
They cancel out.
They cancel out. And now I'm left with 2h over mu k. And that is my equation for D. So I'm like, okay, that's interesting. And I did not put some of this stuff up here, but I also started to work out to see if I could work L into this. And I should have realized immediately there's no way to work L into this, because I would have had sine in there, and there wasn't sine in that other problem. And what ended up happening was I ended up getting D equals D. And I was like, oh, that was
negative?
awesome. Sorry?
Shouldn't that be a negative 2gh or 2 negative 2h?
No, because I'm talking about a distance.
Okay.
I mean, you could put a negative there. It's not going to be right or wrong. It's just, you're just talking direction. All right. So what do I know that is the same and what is not the same? Well, I know that the distance should decrease with the coefficient of friction because the mu k would have to be in the diameter, right? So I know that as my distance, as the coefficient of friction would increase, that should decrease my d, right? I mean, if I have like a sticky surface, then it's not going to go very far. So that means if something's going to decrease as something goes up, then it has to be in the denominator. So right there is something I know, and that's proven right here as well. So I know that the distance should decrease with the coefficient of friction because mu k would have to be in the diameter. Notice, I should have known this piece. I already knew without having to solve anything out. This was just for my sake. I like to work things out. Second piece, the length of the ramp L has no effect on the distance because there is no friction. Well, duh, we already stated that before, that there's the L and the mu have nothing to do with each other because there's no friction. I mean, it's beautiful. It's like it's a gift when you get those type of problems. And hopefully you might have picked that up, that, you know, the L and the mu, they shouldn't really affect each other because they're in different locations. And because there's no friction there, it's the same thing as just dropping it. Can someone read that one for me? Because my screen gets covered in front of it.
The initial potential energy turns into velocity, which is slowed to rest by friction. In a sense, potential energy becomes the energy that the friction dissipates. What does dissipates mean?
So dissipate means, so remember, friction is not really a conservative force. So dissipates kind of means sucked out, goes away, pulls out. It's dissipated. So, I mean, the energy has to go somewhere. It has to be dissipated, or distributed would be a same root word. So that's, I just use the word dissipated. But we do know that all of the potential energy turns into kinetic energy, and the friction has to dissipate or suck out. Don't use the word suck out. That would be bad. Maybe use up. So the friction uses up that other energy. And then one more point, no energies depend on, can someone read that again? Again, it's covered by a part of my
No
screen.
energies depend on the ramp length L.
Okay, now notice something. This is what they asked for. This want to know what elements of that are accurate. And basically the answer is none, but it needed you to be more specific. But all of this work I did, was it useful? Yes or no?
Since they just asked you to explain, it wasn't useful. It was useful in the way that it helped you calculate the answer, but it wasn't useful in answering the problem.
Sure, and that's where I made my mistake. State all aspects of the equation that are plausible, and what's it say afterwards?
Explain your reasoning. That's the more important part.
Explain your reasoning. So basically, what I should have done is just stuck to my brain and been like, because remember, if you've looked at some of the problems we've done, and I'm going to put more up there. So far, none of them have required actual calculation, and I'm looking very hard to find an AP Physics C1 that has integration, because you can't talk your way around integration, really. Either you know how to do it or you don't. And I'm desperately looking for a question like that because I refuse to believe there's not going to be one. But AP Physics 1's a little different. But this is still an AP Physics C level question because it's the same topics. It's asking you to rationalize, and that is what's going to be the focus of this test, rationalizing and understanding. There is no way you could look up this question and find help online, short of finding the answer, obviously, where I got it from, which is Friendly Physics, which is a Facebook teacher, the guy who does APC. He's like really good. That's literally where I got this question from. But there's no way to really look this question up. This is a perfect question as far as what they're going to be asking. What should you think about? Well, you know, I don't think the mu and the L should be related. I think all of the energy from up here is going to turn into velocity here. I think the higher I get my mu k, the higher I get my coefficient of friction, the shorter this d should be, which means realistically that should be in the denominator some way, because that's the only way you can that's the only way you can relate d and mu. I mean, if you're trying to relate two things, because I'm trying to relate d and mu. Okay, let's think about this for a second. D and mu. Well, if mu goes up, what's going to happen to d? Well, it's going to have to go down. Okay, so if that's the case, how does that look? It's got to be in the denominator. Okay, I got you. Now the square root aside, we'll deal with that later. How does d and h relate? Okay, well, if h goes up, what should happen to d?
Should increase.
Absolutely, it should increase. So that looks good. L. Well, if L gets longer, but it's not changing D or H, I'm sorry, how does that relate to D? It doesn't. That's beauty of this question, and that is why I would have totally blown through all of my time on this question if I didn't think about it. I'm not gonna lie. The first time I did this question, I blew through the 10 or 15 minutes it would have given me. I know I did, and I only did, and I get to all the points. But you have to just look. This is a beautiful question. Look at what it's asking, and that's what I didn't do. Look at the equation. D equals mu HL. So just start relating it, okay? And this is where you've got to explain. And you might think when you saw my answer, well, why would I explain that energy one? Because that's relating H to D. As H increases, all of that potential turns into kinetic, because there's no coefficient of friction on this mu. So that's why they're in a direct relationship. Yeah, they're square rooted out. I wouldn't even try to explain that, and you don't in the official answer. L and D, well, they ain't got nothing to do with each other. I mean, if this was, like I said, 5 million meters or 5 centimeters, I think I used feet and inches, it doesn't matter. But mu, this is where I think it's difficult, and that's where my calculations helped. If you increase mu, what happens to D? It should go down. Okay, what does that relationship look like? That's an inverse relationship, which means it's 1 over that number. And that's the key to this problem, which I was totally stumped on when I first did it. I was plugging things in and I was doing all this, which it really didn't ask you to do. I mean, if I'd have turned in this, I don't know that I would have gotten any points, because I didn't answer the question. I didn't look for that key word. That once I, by the way, found those keywords, I went back and redid the question to answer these simple points. What's accurate? Distance should decrease as the coefficient of friction increases. Got to be in the denominator. Length should have no effect on L. I mean, L and D shouldn't be related because they're not. H, okay, as H goes up, D goes up, because as you increase potential, you're going to increase kinetic.
Theta is the same as theta.
Sorry. And then no energy depends on the ramp length. Questions on that one?
Not that I'm aware.
I'm going to stop the recording here. I think. Stop recording. That way I can put it up in a